good. So, okay, let me see. Where's my Zoom? Okay. So, guys, I hope, let me admit a couple of you, 4 more. Okay. So, I hope your evening is going great. Today, well, we're gonna learn about 3D printing, and I hope you guys enjoy. Let me just start sharing my screen. Okay, I think now we're good. My computer is loading. Are you guys able to see my screen? Cool. Okay. Very cool. Yes. Okay. Cool. So we have the couple of sessions before. We have talked about how to learn the basics, learn the fundamentals, and also the pretty cool workshop that David gave us on Saturday about how to start a 3D model or how to approach all the free softwares that are out there. So now we're gonna learn about 3D printing, and what's 3D printing? So 3D printing, it's an evolving technology that translates your 3D model into a physical object. So it's just bringing your idea to reality. So that's what 3D printing does. So it's, so I kind of like put a few words that I use as a product development specialist. Like we use very common or almost daily. So we use 3D printing, we use rapid prototyping, we use a design, we use prototype. So usually we deal with the design and then we make a prototype and then we finish a sample to have a proof of concept or testing. And we work in the product development area and we have engineers, we have designers, we have technical designers, we have model makers, product development specialist. That's me. So this is what I wanted to share with you guys today. So the advance in technology has increased rapidly. As you can see, like before, this technology wasn't available. So now that it's available, it's spreading to a lot of different areas. So I have here a few. So it's benefiting like the health department. I mean, it's benefiting the movies like Pixar, and it's benefiting fashion, benefiting how now do we build cars, how we test cars, jewelry industry, aerospace. And now you're able to even, for example, we have a friend that they do product development and they had a customer that they were gonna operate his dog. And what they did is they did a 3D scan of his dog and then they 3D printed his brain because they were gonna do a surgery on his brain. That way the doctor could practice on a 3D printing scan of the brain of the dog. So that's pretty cool. And at the moment, at the moment they are printing organs, they are printing blood. So later they don't have to request people to donate blood. They just, they could be able to print the blood, and at the moment they're printing organs. So the printing technology has increased rapidly and is changing, evolving. So but it starts everything with an idea and then a 2D and then a 3D, and then you have a physical object. So basically a prototype, it's an idea transformed into a reality. So it starts with a 3D model using all these program. So Tinkercad, it's also free, like Blender, like Fusion 360. So these are the ones that well, Fusion 360 and Blender are the ones that David teach us on his workshop about 3D and how we can start building our design or our sketches. Then we have SolidWorks, we have ZBrush, and we talk about different, kind of like we talk about if you're gonna draw a solid or a surface or a mesh, and basically that's kind of like the way right now that technology is, as someone was explaining to me, that's kind of like the math, how 3 different ways you can mathematically build something, or how the software understanding either it's a surface or it's a mesh or it's a solid body. So a prototype, so I have here the word prototype. So a prototype, you get a lot of information out of a prototype. So what does prototype means? Prototype, it's an idea transformed into a reality. And why will you want to build that prototype? Or my question was, when do you know when you're ready to say, okay, my design is ready to be printed? And I got the answer that once you get to a stopping point that you cannot continue, or you have a lot of unknowns that you would like to answer and get more information about, like there are a lot of unknowns that prevent you from moving forward. Like for example, if you want to know if the details that you build are showing as you're imagining, or the texture, like imagine you're building a dragon and you wanted to see how the texture is looking. That way, if you're going to continue doing more, or you're going to invest more of your time developing that same texture, or if you're going to create a ring, are you going to say, oh, I want to see the ergonomics of it. I want to see how does it fit in my hand, or I want to touch it, I want to feel it, or I want to see how is the dimensioning looking. So if, or proportional looking, I want to compare if you can grab it with your hand, or that's whenever you create a prototype. Or you want to, okay, let's just check the idea, we're on the same track. Or that's when you call like iterations, or version 1, version 2. And so that's what we came up to finish our prototype. So a prototype starts with a concept, and then you build then you have your concept, and then once you have your concept or idea, then you start building it, or a 3D modeling. And then once you finish, you review it, and then no, actually this is for a prototype. This is the life cycle of a prototype. So once you define your concept, or once you have your 3D model, then you build it. Once you build it, you review it, like you're 3D printing your ring or your watch. And then once you build it, you review the dimensions, you review that the length that you wanted, that's exactly what you want. And then that's where I was talking about, you have versions, or you start iterations, or refining more, or the details of the texture that you want of your dragon, or if you're gonna build this bottle, you start thinking about, okay, that's the diameter that I want. Let me see. And then you have your production. Once you're good with your prototype, then you go into production. So on this life cycle, they are imagining having a concept, and then having a prototype, and then build whatever you want in a mass production, kind of like building 2 or 3, and then create. Once you have your prototype that you want, then you start. If you are gonna build, if it's a toy, and then you're gonna build it, are you gonna create a mold for it? Are you gonna make it plastic? Are you gonna make it out of wood? Or you start defining the path. Is it gonna be jewelry? Is it gonna be a tool? Or is it gonna be made out of metal? So then you start defining on the whole production process, which is another, so it's another topic, but today we're just talking about 3D printing. So in order to 3D print, you're gonna need a 3D model. So once you extract a 3D model, basically it's just data points. Like sometimes they're called cloud points. So it's basically points connecting to another points that they're extracting data. And these are all the different formats that they can extract that 3D data points. So we got STL, we got step file, we got IGS, we got OBJ, and I don't know if you guys are familiar, but the most, I think the most common for printers or for 3D printers are STLs, but they could use all of these ones. Okay, so any questions so far? Because now we're gonna go deep into 3D printing. So, I mean, on not 3D printing, but in order to get a prototype, there are different ways you could get a physical part. There are two types of manufacturing a prototype or a piece. It could be subtractive material or it could be additive material. So you can see on the, I have a quick video of both. So let me click on the subtracting manufacturer. Okay, so let's go back to the presentation.
It's never been more important to stay up to speed, and Suddenlink can help with 100 meg internet on our next generation network. Stay connected anywhere in your...
Okay, so now we're gonna go with, as you can see, subtractive manufacture. It's basically subtracting material out of a block. If you have a block of wax or a block of Korean material or a block of stainless steel or any type of steel or aluminum, basically you're subtracting material out of the block in order to get your part with drilling and other type of bits. And so now let me show you a quick video on we already saw that one. that we saw. That's the same video that we saw. Okay, so are you seeing, guys, me or my screen or YouTube? PowerPoint. Good. Okay, so let's continue. So what you saw on the video on subtracting manufacture is very slow. It's a slow process. It's printing it's machining one part, mainly one part at a time. Like you have a block and then it's removing material out of the block. So this is very traditional. It's a very traditional and old process, but people still use it. So mainly it's called CNC machines, and they are based out of axis. Like it started with 1.5 axis, and then through 2 axis, and then 3 axis, which is like X, Y, and Z. And now we have machines that can have up to 9 axis. So it's basically a drilling machine or a milling, and it's just removing material. Let me see if, and then additive manufacture. So we have subtractive and additive. So additive manufacture, it's a very versatile technology. It's very fast. You can get a product in 30 minutes. It's faster than the subtracting material. It's a very innovative, and what it's like the cost effective. It's really low cost effective compared to subtracting. Like you could get your pieces with the same, I'm not gonna say like the same quality, because it's different. We're gonna, on the next slides, I'm gonna explain the different technologies on the additive manufacture, but it's very versatile and it's very innovative process. So we have different technologies inside the additive manufacture. So it starts with a layer, as you can see down here, and then you have your layer formation, and then it's just building another layer on top of the other layer, on top of the other layer, until you got your final product. So in additive manufacture, we talk about 3D printing and rapid prototyping. So 3D printing, it's basically taking your 3D model into a physical object. I think we talk about that. And there's a technology called FDM, which stands for Fusion Deposition Material. And that's where you see all these different colors. Remember the little toy that we had on Saturday? Was made with this technology. It has a nozzle, and it starts kind of like fusing one layer with another layer, or it is fusing the plastic into the plate, and it's building, adding, and like layers and layers. Rapid prototyping. And so some people say they consider the same 3D printing as rapid prototyping. Some people consider it different. Some people consider that 3D printing, it's kind of like more cheap, or a cheaper way to get something fast. And rapid prototyping, they mean by printing more quality, having more like a model, and of course it's more expensive because the quality is higher. So we're gonna have today we're gonna focus on 3 different type of technology for 3D printing, which is gonna be extruded fusion, SLA, and then DLP will be just under SLA, it's just a subtype, and there we're gonna see jetting and binder jet. So first we're gonna talk about extruded fusion. So extruded fusion, it's basically this on the left, the 3D printing. So it's very inexpensive. This is mainly all the 3D printing machines that you see kind of like at Sam's or online, that they're $100 or $200 and they have all these different colors. It's basically kind of, it's plastic or filament that is heated through a nozzle. Then it's fused in the plate, in your build plate. So that's why it's called extrusion fusion. So it builds the printed object layer by layer using a heated thermoplastic filament. Also, it's called fused filament fabrication, or also commonly known as fused deposition modeling. So FDM or FFF, it's basically extruded fusion. And I have here a couple of images that you see how you have your plate that is going up and down. So and then you have at the very top, you have your nozzle, which is fitted by your filament. You see kind of like a red line at the top. So that's your filament that is coming in through the nozzle and is being heated. And the material it's gonna have some support material and your plastic or filament. So you see kind of like the lines, the vertical lines are your support, and then the horizontal lines is your printing material. So you can see it starts with a layer and then it adds another layer, and it's just adding layers through the nozzle. I'm gonna show you a quick video of this example. Are you seeing the video? It says bring, no, okay, let's try this one more time. Okay. Okay. So you can see that the printing is a nozzle, and the plate, on this case, the plate is moving, but sometimes the nozzle also moves. Now the nozzle is moving. So on this type of printers, the quality is not that great, but the price is pretty cheap. Like, it's pretty inexpensive to print a part, and you can control the density inside the part, and it's relative quick on time. Like, so that's why this type of technology is becoming pretty, or it became pretty cheap, because you can get your decent quality print in a decent amount of time. So this type of technology is based out of a nozzle that's heating the material, and that's how it's fused to the build plate, and then to finish the layer and layer until it finishes a piece. So that's for FDM, or oh no, here we go. Okay. Sorry, guys. My computer goes crazy sometimes. Okay, so let's go to, okay. Now let's go with the other technology. The other technology is called SLA or SLS, which is SLA's, it stands for stereolithography technology, and SLS, selective laser sintering. So SLA, it's basically, it could be any liquid material that it's cured using a laser. So you're gonna have a liquid in a container, and through a laser, it's burning or curing the material. So if, for example, if you have a resin on a liquid form, then you're gonna have your plate. So the plate comes up, as you can see in the picture. This type of thing, or this example that I have on the picture, is building upside down. So you have your build plate that is going up, and as soon as the laser hits either the plate, or for example here they have a reflection of the laser. And then the SLS, it's curing the material with well, it's not liquid, it's powder. So the powder is selectively fused together. So these types of machines cures an entire layer within a bath of material. It could be resin or it could be powder, and it used a laser in order to. So for example, on the other one, on the first one that was the fused material or the fused filament, it's as soon as the nozzle extracts the material, it's fusing. But this one, it's completely curing the whole layer. So it's curing a whole layer, and then cures another layer on top of the other layer. So that's basically the big difference. And this one is using a laser instead of a nozzle to cure the material. And then I have an example, but since DLP, it's basically a subtype of SLA, but I wanted to bring it up, but because I think it's used in a lot of industries, because you can have a printing pretty quick, and with the technology on the DLP, it's pretty smooth. You get a pretty smooth surface in a very quick amount of time. So in 30 minutes, you can have a part that the quality of it is really. You're still gonna have supports. You're gonna have you need to have supports to hold your piece or to support your printing. So this resin, it's curing with the light. So SLA cures resin 1 point at a time, whereas DLP cures resin 1 layer at a time by projecting an entire layer at once into the bath. As I was saying, this is a very smooth, very detailed. Depends on the resolution of your print is gonna depend on the resolution of the projector. But you can see like you have a photosensitive suspension, and then that exposure is the technology that is using it, and you're also building your project or your object upside down. So DLP, sorry, stands for digital light processing, and I'm gonna show you a quick video of it.
The Form 1 Plus is a stereolithography 3D printer. Today, we're going to take a look at how it works and put it to the test against parts from an extrusion-based machine. Let's start by taking a closer look at the printer. When we open up the light-blocking cover, we can see a build platform inside. This metal plate is where the parts are made. The Form 1 Plus is a stereolithography 3D printer. Today, we're going to take a look at how it works and put it to the test against parts from an extrusion-based machine. Let's start by taking a closer look at the printer. When we open up the light-blocking cover, we can see a build platform inside. This metal plate is where the parts are made. Underneath the build platform is a resin tank. This clear window gives the ultraviolet laser a path to cure the resin. To start a print, we'll upload a file and fill up the resin tank to the indicator line. You can see the laser passing back and forth inside, hardening the liquid plastic. We'll take our printout and wash it in rubbing alcohol to get the excess resin off. The flower comes with supports on it, and we'll snip them off to finish the piece. Stereolithography is known for producing extreme detail with layers down to 4 times finer than a human hair. The Form 1 Plus lets us take advantage of a library of materials, so we made some other parts to show what these resins can do. A castable resin gives jewelers and engineers an inexpensive way to produce metal parts. This flexible resin is great for simulating different textures, and as we can see, this tough resin can really take a hit. Now let's compare how the Form 1 Plus parts stand up against a filament printer. The stereolithography part comes out nice and smooth, but we can see and feel the ridges on the cup printed with filament. When we break this sample piece, you can see that filament parts quickly snap along the layer lines. The SLA process creates a chemical bond, so our prints take much more force. Today, we took a look at how stereolithography printers work, the types of resins they can print with, and what makes the parts stand out against other desktop machines. If you liked our intro to stereolithography 3D printing, check out some of our other videos. If there are more subjects you'd like to see us cover, please let us know in the comments, and we'll see you next time.
So, what do you guys think? Let's just review the other technology that we have.
This part was reinforced with continuous carbon fiber on a marked forged printer. It's 23 times stronger.
So the next technology that we have, it's called jetting or binder jet. So basically what this technology will do is has a nozzle that it's spraying a layer of material, either support or belt, but it's a whole layer that it's spraying. It could spray powder, liquid like wax, or any other type of powder like metal powder or plastic powder. So first, a thin recoating blade sprays a thin layer of powder or liquid material on the build platform. Then a carriage with inject nozzles, it's depositing droplets of a binding agent, or it's the glue. Like, for example, if you have the powder, then you have the nozzle that's spraying the glue. That will bond the powder particles together. So that will be a layer. And then when the layer is complete, the build platform moves downwards, and then it has another blade that's gonna cut the surface. And then this process is repeating until the whole part is complete. So for example, there are exceptions that whenever you are doing metal, you're gonna need a sintered material, which that material is later you'll have to put it on an oven and extract that material, and then it's gonna shrink. So another example for these machines that we use a lot on our company on the company that I work for, that's James Avery, we do use the technology, this technology, it's called Solitscape. I'm gonna show you a quick video, but it's basically, it's a spreading, or the nozzle, it's spraying either a wax or a support, but it's spraying a whole layer, and then it has a blade that comes and trims it at the right dimension that you want. For example, or the quality, I think the quality that we have could go up to 1,000 or half a thousand. Sorry, I had an ant. Okay. So I have a quick video of how the powder binder works. Let me show you a video. So I just want to pause it really quick. So on this video, what they did is they scan a person, or there's technology out there that you could scan any object by cloud points. So it's putting a lot of points on all the surfaces, and then you can extract that 3 data points that we were talking about and import them into a software. And that's going to be a mesh. And usually it's not perfect, but with the 3D programs, you'll be able to fix it. For example, if it forgot to add detail, or it's missing, it's having a hole, like your surface has a hole, or you forgot to scan one part, and so you will be able to modify it. Go back. So that'll be another way that you could start your design. So over here it's adding glue. So you have layer, and then the build plate's coming down. So Josh is asking about a better quality. So this type of let's finish this one and then I'll answer the question. That was it. Okay. Share. So so it comes to this example. I'll say I'll divide it, divide it into these two. It's either 3D printing and rapid prototyping. Rapid prototyping, why some people call it they are the same, some people call it different. I'll say they are different. For me, rapid prototyping, it's more of a technology that is really detail oriented, and it's more expensive. And you're like, if you're gonna create a model, for example, before they used to carve and create a model, And right now they use rapid prototyping to create a model. And then from that model, they can fabricate more pieces. Compared to 3D printing, 3D printing is it's a very inexpensive way of printing. That's what most people have at home. It's a 3D printing machine that they could 3D print their toys. They could 3D print their a cup, or they 3D print the keychains, or they 3D print basically kind of like personal stuff that they created, or that they want to, that they have an idea, they just want to 3D print something, but the quality is the quality is not there. Like there are a lot of errors on this type of, whenever you are fusing the filament. Compared to rapid prototyping, that technology is more expensive. For example, a 3D printing machine could cost $100 compared to rapid prototyping that they start at 10,000. Or, I mean, depending on the technology, but they could be 25,000, 10,000, or they're more expensive. So the more expensive you get, there's always, so let me explain that really quick. So there's always a trade-off between time, cost, and quality. So for example, this, okay, so share screen. Okay, so do you guys remember the little toy that we had the other day? I don't have it with me today, but I have a quick video of the printer that we used to print each part. So is this additive or subtractive manufacture? Additive, right? Very good, Ramya. So this is adding layer by layer. So can someone tell me what type of technology is this one? Is it fuse filament, or which is FDM, or is SLA, or is using a nozzle, or is using a jet? Someone says it's adding a jet. There are two different. One's a jet and the other one's a nozzle, but they're similar. So FDM. Toby says FDM. Let me go back and explain it really quick, and then you guys tell me. Yeah, it's an FDM. But for example, for this little toy, let me see. So we, so we said we have extruded fusion, which is a filament that is fused into the build plate, and it's very inexpensive. And then we talk about SLA and SLS, which this part of technology is cured with a light or a laser. And it could be powder or it could be liquid. This is the same as a digital light processing, so it's curing the resin. It's a type of SLA. And then we talk about jetting or binder jet. So the jetting was spreads a whole layer of either build or support, and then it has a blade that's cutting it. For example, let me show you a quick video. So this will be a quick video of the technology that we use, that this video is using to print a ring. Stop sharing. Okay, finally. They designed a 3D model. And then what the nozzle is doing, it's spraying a whole layer of build and support. So it has a sacrificial material. So this technology is based out of printing a whole layer. That's what's called jet. So there are different type of printers, right? So one could spray a whole layer of powder.
This was just part of an experiment.
Oh no.
Put some pictures up online, got some good feedback, and decided.
But the video that we saw, it's printing, like, for example, 3,000 of wax, right? And then another 3,000 of support, and then it let it cool because it's wax, and then comes a blade that's cutting the extra wax. So if you want your definition to be 1,000 of an inch, like it's kind of like 4 times smaller than a hair, or about 3 times. A hair is like 3,000 or 4,000, so this will be at 1,000. So it builds a layer that is 3,000, and then it comes and cuts that 2,000 off. So that material, it's sacrificial material that it has to cut it in order to get the definition that you want. And then coming back to this little guy that we printing. So this one, it took about 1 hour to print each piece, and the density, you can change. The good thing about this one, the quality is not that like defined. Like you can feel the ridges. Like you can see that it has like layer and layer and layer, layer, layer and layer and layer. And it goes also by like the density of it. Like you could have it all the way solid, or you could have it, you can change the density. Let me see if I have I don't think I have a picture of the density. Let me see. Okay. Can you see my screen now? So for example, the piece that we saw in the video, it took 1 hour to print, the quality was 0.15 millimeters and a 50% in filament, which is the filament on the inside. You can build a solid or you can build a hollow, kind of hollow with some supports inside. And I put some like the machine itself, it's not that expensive. So I put a few machines that I found online and they go to $176, $200. You can get a pretty good quality or reliable machine for $300 that you're gonna transform your filament. They have different colors. You're gonna transform your filament into an idea. So I encourage you guys to, if you want to become a designer, as David said, I encourage you guys to know your fundamentals, learn your basics, and start drawing or start learning more about it. And that way you could even, if you have an idea, you could 3D model it with the free software that's out there. And you can even buy your 3D printing machine for $200 and start printing your own little toys or your keychains. And then you can even make a business out of it. A friend was telling me about a guy that I don't know what product he was making, but he was able to 3D print another 3D printer. Like he bought a 3D printer and he printed another 3D printer from his 3D printer. And then he had another 3D printer that printed another 3D printer. So he was, I don't know what business he was in, but for me, it was pretty impressive that someone could print another 3D printer machine out of the 3D printer machine. So he had like 6 printing machines, or always one printing another machine. So I hope you guys enjoy the class. This is we end up at a pretty decent time, not with like the other ones that that sometimes I go over. So I'm gonna let you guys enjoy your weekend, and thanks for watching. And if you have any questions, wait, don't leave yet. I wanted to talk to you about our next class. Let me share. So our next class, we're gonna have Eric Haddad, which he is, he's a very good friend of mine. We used to be co-workers, but then he moved to El Paso and he started his own company. And what he does is he does a lot of product development. Like he has 3D printing machines and he creates a prototype. And let me show you his website. I wanted to show you a little bit of his background for our next class. So one of his companies is called 3D Aero Ventures, and he has a passion of building, or he has always liked flying, or I don't know, like aircraft and aero dynamics, and so that's why he created his company. So these are the different models that he had created from scratch, and then he just build them in his head, had an idea, and then 3D model it, and then prototype it, and then testing it. So
hey guys,
let me show you a quick
Welcome
video.
To 3D Aero Ventures. Stay tuned for this video. We're going to show you how we turn this roll of plastic filament into this badass flying wing. So in our last video, my son and I took an off-the-shelf foam glider, hacked it, a quick little pod design, slapped it on the top, and turned it into a fully functional RC airplane. We used SolidWorks CAD and 3D printing to design our little pod. So that was a really simple way to kind of introduce somebody into modeling. In this video, we're getting quite a bit more complex. You know, it started out as me thinking something real simple, like let's just show people how to design a wing, a flying wing, in CAD, 3D print yourself at home and turn it into an RC aircraft. But as I wanted to do, in a shallow effort to kind of make this thing look a little bit cooler, I came up with this infinity wing design, as I call it, or a blended wing design. So technically, is it a flying wing? You could categorize it as sort of a tailless aircraft because it's just the controls on the wing that are controlling it with elevator control and aileron. But I think you'll agree, it looks really cool, looks really unique. And it actually is, there is some science behind this design actually. The two wings should provide a lot of lift for this size of airplane. Yes, it'll provide a little more drag, but it should be a nice, gentle kind of scaled flyer. This is a really interesting kind of problem or project to work on because you're wanting the parts to come out as strong as possible, but also lightweight, it can't be too heavy. So there's a really unique rib design that you'll see designed into these parts. So let's dive into the design process, the 3D printing and building process to this airplane. And then stay tuned to the end, we'll see how it flies. Guys, if you like this video, please smash that like button. Give us a subscribe to stay tuned to other aircraft that we're going to be coming out with and featuring. So thanks for watching. Let's hit that CAD and 3D printing montage.
All in, this aircraft took around 60 hours of CAD design time, so I won't go into a ton of detail on how to model it step by step. I'll just quickly run through the basic method for how the model was designed to actually fly and how it was designed for 3D printability. I started by modeling the infinity wing design with a fully symmetrical airfoil and added the vertical fin for extra stability. I based the aesthetics of the fuselage on a classic full-scale glider look, and I modeled in the actual electric motor and LiPo battery to make sure they fit perfectly in the fuselage design. You'll notice I'm modeling half of the aircraft, which will save me a ton of time in the end since I'll be able to just mirror the design as one of the last steps to create the other half. This plane will be controlled by elevons, that is, the control surfaces cut out of the back wing will provide both elevator and aileron control. With the elevon cut out, I shelled out the entire body, leaving a wall thickness equal to the extrusion width of my 3D printer, which is 0.45 millimeters. At this point, I can start laying out the unique rib design. The ribs are also 0.45 millimeters thick and are designed so they are fully self-supporting during printing. I also incorporated lightening holes into every rib, which sheds a bunch of weight but maintains strength. This is a very similar methodology to how the company 3DLabprint.com designs their 3D printable aircraft, so a big shout out to them for the inspiration. With the internal ribbing done, I modeled in one of the servos so I could design a nicely fitting servo tray. And I designed a tube through the back wing and down the vertical fin for routing the servo wires. Before mirroring everything over, I split the wings and fuselage into manageable 3D printable chunks, and I designed alignment aids into each piece to ensure perfect alignment during assembly. Here's the completed aircraft. Here you get a really clear picture of the unique ribbing design that makes this plane so light and strong. I ended up splitting the aircraft into 30 separate parts for printing in PLA, each part averaging about 3.5 hours of print time, putting the total print time to around 100 hours. Luckily, I have a nice little fleet of printers at the office, so I can knock out the full build in just a couple days.
The results strongly support that these beings are not closely related to any known.
Pretty cool, right? You guys catch that he built it, half of it, and then he mirrored it? Remember on Saturday, David was also sharing or how he built it. He built half, and then he just mirrored the other half of our little toy. I don't know if you catch that.
The assembly process is surprisingly simple and can be completed in just a few hours. I like to lightly sand the mating surfaces of each part to ensure a flat mating surface and to give the glue a bit of grit to grab onto. Using a good quality, medium-bodied super glue that you can find at Hobby Lobby or Home Depot, and a little bit of accelerator gives an instant and sufficiently strong bond. It's really as simple as that for each part. Light sanding, super glue, and accelerator to cure the glue. From there, it's just screwing on the motor with bolts and lock nuts, screwing on the cowling, and setting up the control surfaces. This aircraft has a really cool hinge design for the control surfaces, which uses a 1 millimeter diameter carbon fiber rod running through each wing and each control surface. It's very light and very strong. As far as some technical info about the airplane, it has a 50-inch wingspan, and full flying weight came in at around 1,400 grams, which is a bit heavy for this size airplane, but not out of the specified range of the motor I'm using. which is an E-Flight Power 15 motor, powered by a 3-cell, 2200 milliamp LiPo battery. You'll see all of the details about the aircraft and the equipment used in the video description below. And over the next few months, I'll be perfecting this design, completing full build instructions and a build video, and offering the digital files for sale through our website. For now, head to 3daventures.com, sign up for our newsletter to stay up to date on the availability of our latest designs. With the radio equipment set up and the motor tested, it was time to face my fear of destroying something I spent hundreds of hours developing. Let's see if she takes to the sky.
Before we get to flying this concept flying wing, I want to give a big shout out to SolidWorks for sponsoring this video, allowing me to bring you guys really awesome content like this. Stay tuned for a couple future videos sponsored by SolidWorks. And we're going to actually be featuring a couple of these airplanes at their upcoming event in February, 3D Experience World 2020 in Nashville, Tennessee. We'd love for you guys to be there. Come say hi, check out the airplanes, and just talk shop a little bit. For more information about 3D Experience World 2020 or about SolidWorks in general, check out the links in the description below or with www.solidworks.com. Now back to the video.
People are not asking the right questions. They're not asking the right questions because they kind of think they already know.
That went well. Wow. Whoever said life of an engineer isn't inherently dangerous is really full of it. Especially if you're an idiot. Wow. I'm a little hurt on the inside, a little fearful for my life. It's dangerous out there, guys. It's dangerous out there. I'm gonna go cry myself to sleep, and then let's hit that instant replay and see what went wrong, and then we'll get back to the drawing board. So, woo.
So I'm back in the booth here to do a little video analysis of our maiden flight. It's about at this point right here that I realize this plane is way too tail heavy, and this is not going to end well for me. Luckily, I have cat-like reflexes, and I initiate a solid juke to the left. But if you look closely, it's at this point here that I begin to soil myself, which was most assuredly the reason I slipped on the now wet grass, popping up as quickly as possible in an attempt to salvage some dignity. Finally, taking a quick look around to make sure no one saw this fumbling idiot narrowly avoiding receiving this year's top Darwin Award. So I obviously made a sizable miscalculation on the center of gravity position of the initial design, and I determined I needed to shift the center of gravity forward 6 to 8 inches, which is quite a lot. Unfortunately, the nose on the initial design is so short, there was no room to push the battery forward, and I would have to add a ton of weight to the nose to get it to balance properly, which I definitely didn't want to do. So I redesigned the fuselage, extending the nose about 8 inches, and taking the opportunity to lighten up the rest of the design, removing a few ribs, respacing the remaining ribs, and choosing to eliminate the servo routing tube from the rear wing to cut some additional weight. These changes proved very helpful as it kept the new design right around the same weight as the original design, despite having a significantly longer fuselage. With the memory of my nightmarish maiden flight and the realization that I have very little pride left, I mustered the courage to attempt flight number 2. Cue the overly dramatic music. I can't tell you how nervous I was this second go around. It was actually kind of a natural high to put that much work into something and to see it become a success. And I'm happy to report this plane flies incredibly well. It actually handles like a much larger scale aircraft. It's super stable, almost majestic looking in the sky. It's quite speedy. It would have been awesome if my first attempt ended in a successful flight, but it wouldn't have been nearly as valuable a learning experience. It definitely wouldn't have been as comical. I've had enough failures in life to know this, but this experience reaffirms the fact that sometimes you're going to fail. You're going to make a fool of yourself, but be determined. Pop up as quickly as you can, swallow your pride, and give it another go. Thanks for watching, and remember to never stop exploring, never stop questioning, and never stop playing.
Pretty cool, right? Okay, well, thank you all. And now that we saw the video, you're gonna know a little bit of Eric. He's gonna be giving a tour of his office and his 3D printers and how we're gonna interview him on Tuesday. And thanks for watching. Have a great weekend, guys. Bye.